Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage with one of our virtual labs. I hope you enjoy it.
Welcome to Lab 15. We're going to try our first virtual lab here. I'll show you the procedures and then I'll do some little clips to give you all the data that we have. So let's get started. We've got water, which is right here, distilled. I ended up taking the temperature. Let me take the temperature again to see what room temperature it's at. And it's been standing here for a while. So let me check that temp, because the density of water changes with temperature. And there I got it, 20.2 degrees Celsius, and I'll record that. I've got my lab notebook here, and whenever you do a lab, you write down what you're doing and you put the data down. So let's get that 20.2 degrees Celsius written down, and I've got that as my data. Next thing I'm going to need is to find out how much this empty graduate weighs. So I'm going to turn my balance on so that it gets down to the 0. I'll make sure it's tiered, it's in grams, we're ready to go, and we'll find out what the mass of the empty graduate is, and let it run through and make a double check on it. It's varying a little bit back and forth between 7.11 and 7.12. So it's going to be a matter of me deciding which one it is. And I'm going to pick the 7.11 grams for the empty graduate. And I'll write that down as its empty mass. Now the trick is going to be to find out what various volumes of water are going to be, and I've got to get them in this graduate somehow, and I'll do that using my little pipette bulb, my plastic one, and I'll try and get it so that the water doesn't get on the sides, and I'm going to put in about 2 mLs to start with. Now that 2 mLs is going to be a little bit tricky, and oops, I don't want any air bubbles. I want it nice and smooth. And let's see what I got here. It's going to be hard to read. I'll show you more exactly with a close-up picture, but let's see if I can get all that. No droplets on the side. Get everything in there. And I'm going to fiddle back and, oops, not quite enough. I'm going to put some more water in. And this is going to be the tricky part. Oops, not by the balance. The balance doesn't do well with water. And let me see, there I've got it. Okay, I'll get rid of those air bubbles. That's one of the little hassles here. That's where this pipette's going to come in handy. And I'm going to fiddle back and forth and try and get all that water and find the exact volume. So I get 2.00 mLs, and then I'll find its exact weight. You know, turn my balance on. It's a good thing that I measured the empty graduate. And then it's zeroed out nicely, and I'll get its weight for 2 mLs and 4 mLs, and this is a little bit tricky, so this may not be exactly 2 mLs, but I'm going to write down the exact volume it is. I'll do that little reading, and we'll do that over and over again for all these measurements and record them in our lab notebook, and that's what the experiment is. I'll show you the data that we get for it, and then we'll get to the next step where we analyze our data.
Here's our, well, actually this is not ours, this is my lab data. And as you can see, it doesn't have to be neat. It's something that you're doing while you're doing a lab. I mean, you've got beakers and water and everything else. So writing it is more important than making it super perfect. The data as you take it is important. As you can see, I've got the measured temperatures, and when I took them, I wrote them down. I described the experiment quickly, and I put together a table ahead of time. And the reason I did that is because I knew what the experiment was going to be, and I knew I'd have an empty graduate, I'd have a 2 ml graduate, and 4. And so I can set a table up very nicely, and then makes recording the data a lot easier. So let's take a quick look at this data and then I'll show you how you can use it. I forgot to mention one thing. Uh, you'll notice that I had some errors here. Originally thought I had was going to have 2 mLs for this empty graduate, but I found out it was actually 2.01. Remember, you don't erase. You simply draw a line through any error that you make, and that's fine as long as so that we can see what the original data was. So strong thing in lab reports is that you don't erase data. You just indicate that you think it was wrong by drawing a line through it. I'm going to take the data that I have and put it into an Excel spreadsheet. You can get this Excel spreadsheet on my webpage. And very often, data needs to be graphed to really understand it, especially for this lab. So I'm going to show how to use the spreadsheet and then also a few other little tricks along the line. So here we go. Here is our spreadsheet. I've set it up with this graph, and it's worth learning how to use Excel to do graphs alone. People don't really do graphs by hand anymore. Everything's done electronically, and we've got this Excel spreadsheet set up. You might look it over and see how it's done. Basically, I've got this table set up so that this X, Y data is automatically has its points put in, and I also have it set up so that it puts together a best fit line. We'll go over that in a couple of seconds. First, let me get my data in. So I'm going to take our empty graduate, and I'm looking at my lab sheet right here, and put down 7.11 grams. And you'll see that data point is right there with this little plus. And then I'll get the rest of this data in here very quickly. 11.01. And let me just go back quickly. You'll notice that as soon as I put this second point in, this best fit line got drawn in. These best fit lines are just really, really interesting, and it's a trend line. So it's worth learning how to use this because you can graph straight lines, logarithmic, everything. An excellent tool that will serve you well in the future. So let me get back to here. Here I've got 2 points. They determine a straight line. That's great. And I'm going to put this data in. Now look at this second point as I put this piece of data in, 11.01 grams. And when I put it in, enter, you'll see the third point here. And you might have noticed that the graph adjusted a little bit. Let me mess things up and put in 13 grams here. Notice here's these 3 points, and my best fit line is trying to get the best route through them. And with this point being higher than it should be, it's moved the best fit line up, and it's trying to say this is most likely the average of these 3 points. It's a weighted average, but it's an average nonetheless. The slope of this line is 1.4, 1.5 roughly. Let me get back to the original data, and we'll see 11.01 was what I measured experimentally. And now our graph is adjusted, and the slope is 0.975, which is going to be the density. So let me then go to 13.16 and see if that changes things any. Yep. Look, the density is now 1.035, and with 4 points, my average is getting a little bit more accurate. If one value was a little bit under, one value is a little bit high, taking this best fit line averaging, those of you in statistics will know more about it, is a really powerful way to take multiple pieces of data and use them together to get a more accurate result. So let's see what 15.15 does here. 15.15 grams. And I'll put that in and we'll watch that graph change. There's our point. It didn't change the graph much. We're at a 1.01 grams per ml. And now let's get our last one, our last piece of data here, 17.11 grams. And there it is. Yeah, no, this is pretty much the average that we have. The one point that's a little bit off looks like the 4 ml value. Whoa, almost forgot one thing. This spreadsheet was set up to show you what we had at exactly 2.0, 4.0, and so forth. But actually, my data, when I took it, I couldn't get exactly 2 mLs. I had to estimate 2.01 mLs. And I'm going to put that into the graph and change the graph a little bit. And my 8 ml amount, I just couldn't get that exact 8 mLs, so I got 8.2 mLs. Now this matches my data perfectly from what I have. And you can see there's a little bit of variation, some ups and downs. This value being a little bit higher than our best fit line and this being a little bit lower. And right now I'm getting a density value of 0.996 grams per ml. So this is a nice way of looking at this graph. Now let's go and let's say you didn't have an Excel spreadsheet. Well, let's say you didn't trust this all much, or you wanted to end up seeing what you could figure out for the density for this graph. And I'm going to pull up my calculator here. And I'm going to move it into our screen so you can see a little bit better. If you don't have an Excel spreadsheet and on a test you've got to find the slope of a line, and you'll have to do that quite a very important series of important problems in AP Chem later on when we do reaction rates, where you have to find the slope of a curve. When you're trying to find the slope of a curve, the best way, and to do it quickly, is to take the best fit line that you have and take the two extreme points. The two extreme points will probably give you the best possible results. And of course, slope is y2 minus y1. So I'm taking the extreme y2. This is going to be my 10 ml. And so that was my y value, which is the mass, which is dependent upon the volume, was 17.11 grams. And then the other trick, the real trick, is to go back to the y-intercept, because you have an x value of 0. It's always nice to have zeros when you're doing calculations. And that piece of data was 7.11. So I can get that rise that math teachers are so happy about talking about, rise over run. And our rise was a rise of 10. Oh, no, take that back. No, it was 17.11. Oh, yeah, a nice easy subtraction. You didn't need this calculator. Now, you divide the rise over the run, and because your first value is 0 and you've got your second value is 10 mLs, it's a pretty easy. That's going to be divided by. Let me hit the divided by button here. My last answer divided by, this is a silly subtraction, but I'll do it anyway. My 17.11 was for 10 mLs, and then my 7.11 was for the empty graduate 0 mLs. And of course, we end up getting a density that is shown to be 1, just doing a quick calculation with 2 points, which is very, very close to what we have here, 0.9963. If you round that off, you get yourself a nice density of 1 gram per ml. So that's the manual way of doing it. If you don't take the rise, y2 minus y1 divided by the run, and if you start at 0, just divided by that x2, and you're set. Okay, that's the data. You can now go to the lab report and do the best thing that you can for